Starting on number 1 here, we're looking for an equivalent expression. And what we basically need to do is combine like terms because these two terms both have x to the same power. So 9x squared and 7x squared is the same as 16x squared. And the 9x can just come along. And that's answer choice D. Going to question 2, this is asking us about a percent, which is simply a part over a whole. So we have 900,000 in the entire group, in the whole thing. And we have 828,000 in the part that are silver, which is what we're looking for. And 828,000 divided by 900,000 is 0.92. Now that's in decimal form. To get from decimal to percent, you move the decimal 2 spaces over. So it's 92%, which is D. Now going over to question 3, we're just working on solving this equation, but we also don't want to solve for t because then we may forget and put t in as the answer. Instead, let's do our best to just get directly to 3t. So let's start by distributing here. 6t minus 20 plus t equals 40 plus 4t. Combining like terms, 6t and t is the same as 7t. Now, in one fell swoop, we can take away 4t from both sides and also add 20 to both sides. So that'll give us 3t on this side and 60 on this side. So like we said, what we were looking for is not t, it's 3t. So we're better off just stopping right here and never getting tempted to enter 20 in as our answer. So the answer here is 60. On number 4, very similar to number 3, you have an advantage if you solve directly for x plus 4 rather than getting x and adding 4. Because if you get x, you may be tempted to enter that in as your answer, which you really want to avoid. So here we have 5 of these x plus 4s equals 4 of the x plus 4s plus 29. So one way to think about this is let's take away these 4 x plus 4s from both sides. And right now on the left-hand side, we'll have 1 of these x plus 4s. And often in math, when there's a 1 in front of something, you just don't write it. For instance, x is really 1x, but we don't write the 1. So x plus 4 is the same as 29, and that's what they were asking us for. Going on to number 5 now, this is a question that we refer to as linear with heavy unit conversions. The idea here is that in general, you should lean toward using chemistry-style unit conversions so that on this and other hard-level questions, you can be well prepared. A lot of times when you're converting units, you can just multiply by 60 or divide by 100, something you've been doing your whole life. But there are harder questions where you really need to know how to apply a unit conversion method. And we think this is one. So if you just always do your conversions the same way, you'll be in a better position. So let's start by leaving a little space, and you'll see why we're doing this in a second. So for some of these items, we know the units, and for some we don't. For instance, we know that 3,934 is the total number of trees. Another thing is for all of these, we want to realize that all of these numbers are really themselves over 1. Any number is itself over 1. So we have 3,934 trees. We have 2 as the number of hectares. And we have x as what we're being asked about, so we'll leave that for later. 35 is also the number of hectares. Now, the 2 was said to be the number of hectares for the park. So all of this pertains more to the park, whereas the 35 is for the residential area. So now we'll leave some open parentheses here to signify the unknown unit on the x and on the y. Now, we have hectares here and here, but in the end, we end up with trees. So what do we need to multiply hectares by in terms of unit conversions to get trees? And the answer is really an easy one. The answer is trees per hectare, and I'll show you why. So I'll put trees per hectare here, trees per hectare there. And what happens is hectare cancels with hectare. Hectare cancels with hectare, leaving you with what unit? Trees, which is what we really needed. So we set things up so that they'll cancel in a way that gives us the unit we want. And we decided what unit has to go in the empty space in order to make that happen. Now that we set it up and we understand it, we can answer their question. What is the unit that goes along with the x? X is the number of trees per hectare for every 1 hectare as it pertains to the park. And which answer says that? A, the average number of trees per hectare in the park.
Don't wait. Join now for access to exclusive SAT lessons, practice problems, and solutions to questions from the SAT Question Bank.
Going on to question 6, here we're talking about a ratio between a length and a width. The initial ratio in the rectangle of the length to the width is 35 to 10. Now the width is increasing by 7, so the new width will be 17. So what does the new length have to be? We can just make a proportion out of this, cross multiply and solve. 35 times 17 equals 10 times x. Now we get 595 right here. Divide both sides by 10, and you'll get x is 59.5. So what's our answer? How must the length change to maintain that ratio? Well, the length started at 35. It went up to 59.5. Therefore, it increased by 24.5 units. Going on to question number 7 now. This is what we might call a rational equation because it has a variable in the denominator. And for rational equations, you generally want to just multiply both sides by your unwanted denominator. So for us, that means multiplying both sides by n. Now, a quick word. When you first get to this question, you see all of this explanation of all this stuff. And p has to be greater than 9. And that'll get a lot of students hung up. They'll wonder, like, okay, what does all this mean? It looks complicated. And also, why does p have to be greater than 9? And really, once you're at a point where you know what math instinct you want to use next, you really should ignore a lot of the other stuff. A lot of that other information may help you choose between 2 answers in the end or something like that. But for the most part, it'll throw you off. So in any case, we're multiplying both sides by n. That's going to give us np. Right here, we'll have 9n. And here, the n on the top, which is on the outside, will cancel with the n on the bottom on the inside. So you have n canceling with n, and that leaves you with 14 there. Now we're trying to get n by itself. So from here, the thing to do is to take away 9n from both sides, because if we want n by itself, we want to get everything that has an n on one side of the equation. That'll allow us to factor n out. And what does that leave us with on the inside of the parentheses here? P minus 9. So now, if we want n in terms of the other variables, now we can just divide by the p minus 9. Not p minus q, p minus 9. And so this will cancel, and n equals all of this stuff, which is answer choice D here. Now going on to question number 8. Now, I've been an SAT, ACT tutor for more than 15 years, and I'm one of the more specialized SAT, ACT tutors in the world. And this question made my brain hurt until I realized what they were really doing. So this question is just a reminder that it's all the more important to know your background concepts. Whenever you see us on our gradeful videos go over to these different side screens, these are the recurring concepts that come up a lot on the SAT. And you really need to know them well, because that's the way to really get better, is to kind of understand the concept behind the question and how that concept gets permeated in different manners on different questions. So let's just review for a moment the exponential equation. Exponential equations are generally in the format of a times b to the x, where a is the starting amount, b is the way it changes, and x is the number of times that this all happens. It's very common on the SAT to see this exponent turn from x to x over some number. So if I started with a certain amount of money and it changes, instead of changing every year, if I see x over 3, that would be a change happening every 3 years or every 3 hours or whatever x represents. If x is the number of months, then x over 3 would be every 3 months. And I'm just randomly picking the number 3 just to have a number there. Now, coming back to this question, trying to understand it, we have something increasing by a factor of 27. So if we're thinking back about the easier a times b to the x, b is how it changes, how it increases or decreases. So we really need the number 27 there in one way or another. And which answer has 27 there? Really, this one right here does, because 3 to the third power is 27. So does the rest of it fit? Well, this part right here, the 1 over 6x, that can also be stated as x over 6. And so it's kind of matching this. So x over 6 would be every 6 whatevers. And so let's see what's being said here. It's increasing by a factor of 27. And it's saying at the beginning, each increase in the value of x by c causes this thing to increase by a factor of 27. Which form shows 1 over c as a coefficient? So if we think about that, as x goes up by c, and then we're talking about 1 over c, that's another way to say what we've been saying. For instance, let's just say this thing goes up every 6 months, because that's the way we've been thinking about these as time periods. So now as x goes up by 6, let's say, if in some scenario x were the number of months, so that's another way to say every 6 months, because the number of months went up by 6. And what we said in the beginning was, if this change was happening every 6 months, we would see that in our equation as 1 over 6, or x over 6, better. So that's exactly what's happening here. Instead of having x in the exponent, we're having x times 1 over 6. So as x is going up by 1 over 6, we're multiplying 1 over 6 by our x, we're getting the equation to increase by a factor of 27. So it's very complicated here, but we're dealing with this SAT wording, and absolutely, out of this question type, this is the hardest one I've ever seen. But it's just more reason for you to realize that you've got to make sure when you see these side screens on our videos that you really come to understand those concepts, because they are so fundamental to your success. In any case, the answer here is B. Now going on to question number 9. Here we have a circle equation, and that's something you definitely want to know by heart. The circle equation looks like this. X minus h squared plus y minus k squared equals r squared. H and k are the coordinates of the center. R is the radius. And you want to look out for minus sign confusion. That's because whenever you have a negative sign in the formula, it means that what you see is the opposite of what's really happening. For instance, if I have x plus 5 squared and y minus 6 squared equals 25, the center would be negative 5, positive 6, because plugging in negative 5 would look like this, and then you'd get the positive. And plugging in positive 6 would look like this. And of course, the radius is 5, because this number is not your radius, it's your radius squared. Coming back over here, in the original question that we're getting, we know that the center is negative 5, 5, and the radius is 2. That's because our r squared in our equation, because by the way, this is x minus h squared, y minus k squared equals r squared. So what was in the r squared spot was 4. And if you take the square root of both sides, you would get that the radius equals 2. So that's our original center and radius. So now we're being told that there's another circle. So this is circle A here. Now we're being told about circle B. It's got a radius that's double. So the radius is 4. And we're looking for what number goes here. Well, in our equation of a circle, if the radius is 4, we'd have 4 squared right here. And that would become 16. And so K is 16. Going on to question number 10 now. Here we have a business owner purchasing the same model of a chair for each of 81 employees. So let's say that the price of each chair is X, and there are 81 employees. So 81X represents the total amount of money being spent on chairs initially. Now, there's a 7% tax. So if I take anything and increase it by 7%, it would look a little something like this. If you increase or decrease any number by a percent, you always start at 100. From there, you can increase or decrease by whatever number. In this example, it's 25. In ours, it's 7. That'll bring it up to 125 or down to 75. And then in decimal form, you'd have 1.25 or 0.75. In other words, increasing something by 25% means multiplying it by 1.25. Decreasing by 25% means multiplying by 0.75. So coming back over here, if we're increasing something by 7%, 7% sales tax, we would add the 7 and we'd get 107. In decimal form, that's 1.07. Because to get from percent to decimal form, or the other way around, you move the decimal 2 spaces. So we're going to take this, multiply it by 1.07. And we were told that the entire budget was 14,000. In other words, all of this must be less than or equal to 14,000. And now we can start solving. Let's multiply the 1.07 times the 81 on the calculator. So 1.07 times 81 is 86.67. Divide by 86.67 on both sides. So 14,000 divided by 86.67 is 161.53 and some other decimals. But that matches answer choice B here.
Don't wait. Join now for access to exclusive SAT lessons, practice problems, and solutions to questions from the SAT Question Bank.
Going on to question number 11 now. Here, we're being asked for the intersection of these two functions. And for intersections, you want to get both equations in the y equals format and set them equal. So for us, we can take away 8x from both sides here, and we would have y equals negative 8x minus 11. And on the other one, we can take away 341 from both sides. It will have y is 2x squared minus 341. So we got them both in the y equals format, and if we set them equal, we'll have negative 8x minus 11 equals 2x squared minus 341. And now we can remind ourselves that this is a quadratic, and quadratics are situations where, first of all, they have some variation of y equals x squared, but when you have them equal to 0, or something that can be set equal to 0, that's what you want to do. You want to get everything on one side equal to 0 with the x squared term being positive. And so for us, that'll mean adding 8x to both sides and adding 11 to both sides. So then we'll have 0 equals 2x squared plus 8x minus 330. We can make this a lot nicer looking by realizing that there's a common factor of 2 and dividing everything by 2. So we'll have 0 equals x squared plus 4x minus 165. And so now we have a quadratic, and our first choice in quadratics, especially when they're equal to 0 already, is always to factor them. Now, in our situation, we have something that has a b and a c coefficient. So that'll be bc factoring, where you need two numbers that add to b and multiply to c. If you want to know more about the difference between BC factoring and ABC factoring and how to start the two of them, go ahead and pause the video and read this longer explanation. But for us, we need two numbers that add to 4 and multiply to negative 165. They multiply to a negative, which means that they have opposite signs. And they add to a positive, which means the bigger of the two numbers is positive. So now a lot of people, if they have to factor something like this, will be very intimidated by that because it's got that giant number 165. But really, there are a lot of situations like that on the SAT, and you want to be in the habit of just quickly dividing by everything you can before you have time to complain or think to yourself, this would take a long time. So on my calculator, I'm going to divide 165 by 1, by 2, by 3, by 4, by 5. On maybe using common sense, realizing that there are certain numbers that can't be divided by. And I'm looking for the combination that if you add them up, you'll get 4. And it took me as long as this to figure out that this factors to x plus 15 and x minus 11, because those are the two numbers that would add to positive 4 and multiply to negative 165. Now we have our zero product rule, which says that we're going to set each of these equal to 0, and we'll get x is negative 15 and x is positive 11. So what is a possible value of x? Negative 15, or positive 11. So we couldn't have picked B because that was negative 11. So the answer here is A. Now going to question number 12. This is a unique situation that we refer to as splitting an equation. This is maybe one of the easier versions of this question, but we're going to see some harder ones. This is something of interest to students who really, really want to pursue that top score. It's one of those scenarios that only comes up once in a while, but when it does, you need to know what I'm about to tell you here. So the scenario is called splitting an equation, singular. And these situations always involve linear expressions on both sides of an equal sign, kind of like we have here. These are both linear because they both have x only to the first power. Not to say that anytime you have linears on both sides of an equation, you should do this. But if you get to a lot of these and look for videos on this concept in the future, then you'll learn to identify the situation when it comes up. So we've got linears on both sides of an equal sign. When that happens, you're going to split the equation. In other words, you're going to set each of the left and the right sides equal to y. Here, that would look like this. Y equals this thing, and y equals this thing. And from there, what happens is it becomes another common SAT situation, which is a little more straightforward. Now, before we get into that, let's just talk about why we did that. The logic is that if we had to find an intersection, what we're supposed to do is set the two equations equal to one another. So the opposite must be true. If we see an equal sign with two things on both sides, in theory, we can imagine that what we're seeing is an expression of an intersection, and we can take it back apart to figure out what were the two functions that must have intersected. And if they're lines, then what we're also talking about is the three ways two lines can interact. They can hit once, never, or all the time based on what's happening with their slopes and y-intercepts. One solution, no solutions, or infinite solutions. So when we're doing it here, we need to simplify. Y equals 150x minus 90. And here, y equals negative 90 plus 150x. If we just reverse the terms here, we'll have 150x minus 90. So we have one solution if our slopes are different. That's why they're hitting, because the slopes are different and they're tilted in different directions. We'll have zero solutions if the slopes are the same and the y-intercepts are different. That's another way to describe something that's parallel. And infinite solutions if the slopes and the y-intercepts are both identical. Everything's identical because they have the same location. And so here, that's what we have. We have infinite solutions because the two slopes are both 150. The two y-intercepts are both negative 90. So how many solutions are there to this situation? Infinitely many. And so the answer here is C. Going over to question 13 now. Here, we're being asked about a quadratic, which is a parabola. We have the vertex and then the x-intercept. And we're being asked, where's the other x-intercept? So let's get a little mental image of what this looks like here. So we've got our vertex at -3, 6. So it's around here. Our x-intercept is -17/4, 0. Now putting that in the calculator, or just figuring it out by algebra, by arithmetic, you can find out that that's -4 1/4. So let's go to -4, let's paint -5, and -4 1/4, let's say it's around right here. So in other words, we have half of this parabola, and we need to figure out where is the other half. So let's just draw a little dotted line here. That's x equals -3. And let's find the distance from here to here. Now, an easy way to find distance when you're sort of vertical or horizontal is to simply subtract the big number minus the small number. And that'll be a little more confusing when you're dealing with negative numbers. And that's actually -3 right there. So you're dealing with negative numbers. So you need to do the big number minus the small number. So that's -3 minus the -17/4. Now you can do this the natural way or by calculator. You're going to get the same answer either way. So -3 plus 17/4. -3 is really -3/1. Multiply by 4/4 to get common denominators. And we have -12/4 plus 17/4 is giving us 5/4. So we just figured out that this distance here is 5/4. So now what we want to do is we want to go 5/4 in the opposite direction. So we'll take that -3 that we started at, and now we're going to add 5/4 to that. Well, any number is really itself over 1. We can multiply by 4/4 to get the common denominator again, and we'll have -12/4 plus 5/4 gives us -7/4. So we just found out the x value of the other x-intercept. It's x equals -7/4 when y equals 0, and that's answer choice B for number 13. Going over to question number 14. Here, we have this little tidbit of information here that a large percentage of the students who take this question would neglect to see. There's just something about this information in this little spot that makes a lot of people, maybe even most people, miss it. But remember, when we're talking about function shifts, otherwise known as translations, you have two main things that can happen. Let's just say, for instance, if you have a parabola right in the middle, if you add to the outside of that, it's a vertical shift. Vertical shifts are normal. So if I put a number on the outside, +5, that means I'm shifting vertically, and it's normal. Positive is up and negative is down, just like normal. So this would be up 5. Instead of having its vertex at 0, 0, it would have it at 0, 5. Now, if you add to the inside, that's a horizontal shift, and those are backwards. So the inside is the parentheses. In other words, right where x was, we're replacing that with a parentheses that has x plus 5. So that's adding to the inside, and it's not normal. It's backwards. So if positive is normally to the right, then here positive is to the left, and negative would have been to the right. So this is left 5, and the vertex here would have been -5, 0. Now, as far as this relates to f of x statements, if this is our regular f of x right here, then this would be f of x plus 5, and this is f of x plus 5. So coming back to this question, we started with f of x plus 14. That's the outside. It's normal. So this represents the idea of going up 14. Now, to make it more complicated, the question is saying, when we first started this thing, it was already up 14. Let's write that. It's already been moved up 14. So therefore, what are we going to do to this? Therefore, we're going to move it down 14. So just imagine our line is generally right here. If we're going to move that thing down 14, that's like sliding it like this. By 14 units, it's going to go from +2 to -12 for its y-intercept. By the way, slope is rise over run as you go from left to right. So if I pick a point from here to here, you can kind of see that it's going down 1 and over 4. That's why all these slopes are -1/4. But the y-intercept for all these functions that are in y equals mx plus b format, the y-intercept is going from 2 to -12 because it's going down by 14. That's why the answer here is A. Coming over to question 15 now. let's just stop for 1 second right at the beginning and think about what kind of function this is. If it's a linear, x and maybe y would be to the first power. If it's a quadratic, you'll have x to the second power. Or you'll have y equals x to the second power, or some variation of that. Here, this is a quadratic. The other big thing I want you to notice is that they're talking about the number of solutions for a quadratic. So the number of solutions in SAT math is sort of a really important idea. If you had the number of solutions for lines, which we don't here, but if we had the number of solutions for 2 lines, that would be a reference to this idea that there are 3 ways that 2 lines can interact. They can hit once, 0, or all the time, and all 3 of those have different ramifications for the slope and y-intercept. But if you have the number of solutions for a quadratic, that's a reference to the idea of the discriminant, which is this yellow part under the radical in the quadratic equation. First of all, if you don't already, you have to have this quadratic equation memorized. And the discriminant is the idea that just this part here has an impact on how many answers you can have. If it's positive, you'll have 2 answers. If it's 0, you'll have 1. And if it's negative, you'll have none. And it's not by memorizing that we know that. It's by the fact that if you had a positive number, you'd be adding and subtracting. If you had 0, you wouldn't be doing anything. There, the answer would just be 2/3. And these are numbers that I've made up, by the way. And if you had negative, that would be game over because you're not allowed to have a negative under a radical. So when we're in a question like this, and they're saying we have a quadratic situation and we have more than one solution, we have really 2 solutions. Because a quadratic is a parabola, it's impossible for it to hit the x-axis more than 2 times. But this is all just simply a reference to the idea that b squared minus 4ac must be positive. And this is your a, this is your b, this is your c, because it's in the format of ax squared plus bx plus c. So b squared minus 4ac would be b squared minus 4, 64, 25, and that's greater than 0. Now we can start multiplying 4 times 64 times 25 on the calculator. That's 6,400. So b squared minus 6,400 greater than 0. Add the 6,400 to both sides. And now we'll be taking the square root of both sides. Something kind of curious happens here, though. Let's just say, off to the side, that we had x squared equals 25 in some equation. When you take the square root of both sides, you end up with x is plus or minus 5. And you don't always need to use the plus and minus. It doesn't always come up, but you need to always know it's there because when it does come up, you have to be ready for it. Similarly, if we had x squared greater than 25, and we took that square root of both sides, again, well, instead of having plus or minus 5 like we did before, it's a little more complicated now. On the plus side, we can just leave everything the same and x is greater than 5. But for the part that would have been the negative 5, the inequality is going to reverse. So this is going to be x is less than negative 5. And think about that on a number line. X is greater than 5. X is less than negative 5. So for this particular example that I made up, the solution would be there and there. So similarly for ours, we have b squared greater than 6,400. Square root of 6,400 is 80. So this is going to be b greater than 80, b less than negative 80. Now greater than and less than, those are very strict words. That means the solution cannot be where the 80 or the negative 80 is on a number line. So you have negative 80 here, positive 80 here. The solution has to be north of the 80. It could be 80.00001, but it can't be 80. Or south of the negative 80. So anything smaller than that except for the negative 80 itself. So which of these answers fits in there? Well, the negative 91 is like right around there, I guess. And so that would be answer choice A. Going to question 16 now. First, let's notice that these are both lines. They're both lines. They're both linear equations because x and y is to the first power in each of them.
Now, whenever you have two equations and you're being asked for the answer or which point lies on the graph of each equation, anything like that, that's just talk for the solution, otherwise known as the intersection. And there are three ways the solution or intersection can pan out for two lines. They can hit once if the slopes are different. They can hit never if the slopes are the same and the y-intercepts are different. Or they can hit all the time if they have the same address. In other words, if they have the same slope and y-intercept. All of this implies that you have to get it into the y equals mx plus b format to be able to figure all that out. So let's start with the first equation. 2x plus 3y equals 7. We're going to get y by itself. So we'll take away 2x from both sides. Then we'll divide by 3. And so we have the first equation in y equals mx plus b format. Now, let's do the second equation. We have 10x plus 15y equals 35. We'll take away 10x from both sides. We'll divide by 15. And let's simplify all these fractions. So here we'll have, if we divide by 5 over 5, we'll have negative 2 over 3 x plus, and divide by 5 over 5 again, 7 over 3. And guess what? This equation is identical. Both of these things totally match each other. And that is the idea of having infinite solutions. We got the addresses of both of these lines and they were identical. In a way, you can say they're the same line or two lines in the same exact location. When are they hitting each other? They're always hitting each other. So whereas the solution in this situation is a single line, whatever that x and y value, that's the solution. Here, there's no solution. But here, the solution is really weird. Anywhere on that line, and you're in the solution. So this entire equation here, this equation is the solution. Now, this very particular question that you can kind of recognize in sort of the SAT literature, the question bank and such, you kind of see this exact question with different numbers. And basically, it's the idea of having a verbal statement. So without really explaining to you why, I'm just going to solve this. In addition to solving for y, I'm going to solve them for x. So let's take this equation again. 2x equals negative 3y plus 7. So it took away 3y from both sides and divide by 2. Negative 3 over 2y plus 7 over 2. So we have the same solution expressed in terms of what the y equals and in terms of what the x equals. So to be anywhere on that line, the y value needs to be equal to negative 2/3 times the x value plus 7/3, or the x value needs to be equal to negative 3 over 2y plus 7 over 2. Now, let's repeat those two verbal statements again. The y value is what you get when you multiply the x value by negative 2/3 and then add 7/3 to that. Now that is our green statement there. That's either of these statements. They both say that the y value is what you get when you multiply the x value by negative 2/3 and then add 7/3 to that. Now, to use a verbal statement to express the blue statement, that one would look like this. The x value is what you get when you multiply the y value by negative 3/2 and then add 7/2 to that. So what we have right here are two verbal statements, two times where we got one of the variables by themselves and then just kind of spoke out the words of what that really looks like. So now, which answer matches that? Looking at the answer choices, if you look at, let's say, C, for instance, this one says the y value, which is this thing. This is the y value because it's after the comma. The y value is what you get when you multiply the x value, which here happens to be r. You're taking that x value, you're multiplying it by 2/3. Now we already messed up because we were looking for the y value is what you get when you multiply x by negative 2/3. So multiplying x by 2/3 gets rid of that one. Now let's look at another answer. Let's look at D. D says the y value, which is this, is what you get when you multiply the x value, r. Now, by the way, guys, r is just some random thing that signifies like some x value. So this is saying the y value is what happens when you take some random x value and you multiply it by -3/2. Well, here we messed up again because the y value is actually what you get when you multiply the x value by -2/3, not -3/2 like we have right here. So we've already gotten rid of answer choice D right there. Okay, let's go to B now. B says the x value, which is before the comma, it's this. It's what you get when you multiply the y value by -3/2. Okay, let's follow that. The x value is what you get when you multiply the y value by -3/2, check, and then add 7/2 to that, check. Okay, so that is our answer. It matches one of our verbal statements. So in this question, when you have the number of solutions for 2 lines, which is a common starting point, but then you see the answer choices looking like these expressions, it should remind you that we're looking for verbal statements. You solve for X and you solve for Y. You put together a verbal statement for each, and then you start to match that up with the answer choices. A very important question on the SAT. Don't wait. Join now for access to exclusive SAT lessons, practice problems, and solutions to questions from the SAT Question Bank. Now going to question 17. Here we have 2 linear situations again, and we're very literally being asked about the number of solutions. So just like question 16, question 17 is about the number of solutions for 2 lines. So 2 lines can have 1 solution if the slopes are different, 0 solutions if the slopes are the same, but the y-intercepts are different, and infinite solutions if the slopes and the y-intercepts are the same. All of this implies getting it into the y equals format. So let's start doing that. Let's get y equals for both equations. On the top one, we have 4x minus 6y equals 10y plus 2. Let's take away 2 from both sides. And let's add 6y to both sides. So -2 plus 6y plus 6y. So right now we have 16y equals 4x plus 2. Reversing it, 16y equals 4x plus 2. Divide by 16. Divide by 16, divide by 16, divide by 16. And we have y equals 1/4 x plus 1/8. Now let's do the same thing to the other equation. We start with ty is 1/2 plus 2x. So let's make a tiny little change in the beginning. 2x plus 1/2. Now we'll divide by t, and that'll cancel right here. And we have y equals 2/t x plus, now simplifying this, that's like 1/2 divided by t, or t/1, because any number is itself over 1. And keep, change, flip is the idea that we have to keep the first one, change it to multiplication, and flip the second one. So for dividing fractions, you use a method called keep, change, flip. And so now we have 1/2t, and that's what this is, 1/2t. So what does no solutions mean for 2 lines? It means that the slopes are the same because they're tilted the same way, but the y-intercepts are different. For us, it's really important right now to know that the slopes are the same. So what are our slopes? These are both in y equals mx plus b format. And the m is the slope for each of them. So here the m is 1/4, here the m is 2 over t. So all we need to do is set those equal. 1/4 equals 2 over t. And you can see that there's a multiple of 2. So this is going to be 8. Or you could cross multiply. 1 times t equals 2 times 4. Either way, you get t equals 8. And that's our answer for number 17. Going to number 18 now. Here we have an isosceles right triangle. And we're being given the length of the hypotenuse. What you need to know is that any isosceles right triangle is always a 45, 45, 90. Now we're given the ratio for 45, 45, 90 on the formula sheet, but really you should know it by heart. It's easy. X, X, X root 2. So we can just draw a right triangle here. Not to scale. And we can label the sides X, X, X root 2. Now we're being told the hypotenuse is 58. So we can do a little work to sort of solve that. If X root 2 equals 58, right now X is being multiplied by root 2, so you can divide by root 2. That cancels, and we have X equals 58 over root 2. Now we can simplify that further, but for now, let's just leave it like that. The perimeter is just simply the three sides added together. So it's X plus X plus X root 2, or X is really 58 over root 2 plus 58 over root 2 plus 58. So simplifying a little, these two have the same denominator, so we can add them. So that's going to be 116 over root 2 plus 58. And now let's start simplifying a little. Let's rationalize the denominator. We can do that by multiplying by root 2 over root 2. Now, by the way, this entire thing here is simply the number 1 because it's a fraction with the same thing on the top and the bottom. But this is called rationalizing. It allows you to cancel out that denominator. So let's continue down below. On the top, we have 116 root 2. And on the bottom, we have root 2 times root 2, which is just 2. Plus 58 still. And 116 over 2 is 58. The root 2 comes along, plus 58. And that matches answer choice C here. Going over to question 19 now. Here we have an XY chart, because f of x is just a fancy way to say y. And we're being told that this is going to go into the y equals mx plus b format, because that a is in the slope position. So all of this fancy f of x talk aside, we're just being asked to find the equation of a line. And to find the equation of a line, you simply need to use the slope formula to find the slope, and then choose between the slope-intercept formula and the point-slope formula, depending on whether or not you have a y-intercept. So here, do we have a y-intercept? Well, to find x and y-intercepts, you have to be reminded that the x-intercept is just the moment when y is 0. The y-intercept is the moment when x equals 0. So if we want a y-intercept, we're looking for x to be equal to 0, and we're not being given one of those. So we're not going to use the slope-intercept formula because we don't have a y-intercept. Instead, we're going to use the point-slope formula, which looks like this. Y minus y1 equals mx minus x1. So first, we'll get the slope. Slope is y2 minus y1, so this minus this, over x2 minus x1, 2 minus 1. So 0 minus negative 64, that's 0 plus 64, over 2 minus 1, which is just 1. So that's 64 over 1, which is just 64. Now we'll plug it into that point-slope formula. And let's take the easiest point we can take, which is this one right here. So y minus 0 is 64 64x minus 2. Go ahead and distribute the 64. You'll get 64x minus 128. So now that is our ax plus b. And we now know that a is 64 and b is negative 128. So a minus b is 64 minus negative 128. So 64 plus 128, and that's 192, which is D. Going over to question 20 now, we're being told that there's data set A. It has 10 integers. 9 of them are right here. And we need a 10th one to make it data set A. So in other words, we know 9 of the numbers. We don't know one of them. Next, we're told the average, the mean of the numbers is 42. But if the mean of data set A, which is when we include the x, if that mean is greater, then it means that x has to be a greater number than 42. So just repeating that, the average of these numbers is 42. If we throw in the 10th number and it makes the average go up, then it means that this 10th number must have been a greater number, because greater numbers pull the average up and smaller numbers pull the average down. The only way the average could stay 42 exactly by adding in another number is if that other number were exactly 42. Then it would keep the average right where it is. So at the small end, we know that that last number needs to be greater than 42. It can't be equal to 42. Now, let's talk about the high end. We know that all of the numbers are less than 60. So that includes the last unknown number. It also has to be less than 60. The last thing we're finding out here is that the mean itself has to be an integer. That's a pretty big deal. If you add up all these numbers and then divide by 10, it has to be an integer. That kind of means that the sum of all the numbers must itself be divisible by 10. But let's work that out a little bit. So when you add up all the green numbers, you get 378. So we have 378, and then we have the last number. And if we were to divide by 10, that would be our average. And that's just simply the idea that the average of a bunch of numbers is the sum of all the numbers divided by the number of numbers. Now, if that last number is at the small end or the big end, we can kind of figure out both of those limitations and then figure it out from there. So let's say that we had 378 plus 42 over 10 versus 378 plus 60 all over 10. Now, by the way, you can't have 42 or 60. Those are exactly the limits. You can have a number that's just greater than 42 or just less than 60. But we still want to put in those exact numbers because it'll tell us exactly where the wall is of what numbers are allowed. So if we add the numbers on the left, we get 420 over 10. And if we add the numbers on the right, we get 438 over 10. So remember, what we're looking for is for the answer to be an integer, not a decimal. Now, this one here would have given you an integer. If you divide 420 by 10, you get 42. But remember, that specific number combination is not allowed. This one here would not have given you the integer. 438 divided by 10 is 43.8. So now thinking about all the numbers in between, that would be 421, 422, 423, all the way up to 438. So every possible number. So which of those numbers in between 420 and 438 is divisible by 10? And there's only one answer, and that's 430 over 10. That'll give us an average of 43. And so now the average would be an integer. So all we need to figure out is what number do we need right here to make the average come out to 430. And that's really easy to figure out. Let's just do some math off to the side. 378, oops,
378 plus an unknown number is going to give us 430. Take away 378 from both sides, and you get 52. And that's our answer for what x needs to be. Now going over to question 21, here we have a situation where the museum is charging a certain amount for the first 25 people and a different amount for additional people after that. We call that subscription algebra, or the algebra of included amounts. For instance, in the 1990s, cell phones became popular. At that time, you'd pay about $40 per month. That would include around 700 minutes. After that, you'd pay 35 cents per minute. The equation would look like this: 40 plus 0.35, and the included amount would be x minus 700. In other words, you would only pay the 35 cents for amounts over 700. Now, this equation only works if x is greater than or equal to 700, but it does work. For instance, if you spoke 710 minutes, this whole thing would be equal to 710 minus 700, which is 10, and you'd pay the extra 35 cents 10 times because you went 10 minutes over on your included amount. Similarly here, the cost is $21 for the first 25 people, and after that, it's $14 for each additional person after the 25. So now just thinking about how this makes sense, if x were 30, this whole parentheses here would be equal to 5, and you'd pay the 14 5 times because 5 more people came than what was included in the initial amount. So now we're just going to go ahead and do some of the arithmetic here. 21 times 25 is 525. And we're distributing 14 times x, and 14 times negative 25, which is negative 350. And so now 525 minus 350 is 175. So we'll have 14x plus 175. In this question, they didn't use x, they used n, but it's the same idea. 14n plus 175, and that is answer choice A. Going over to question number 22 now. Here we have two triangles, LMN and RST, and we're trying to get these two triangles to be similar to one another. So what you basically want to do is draw two equilateral triangles. They're not going to end up being equilateral, but we don't really care. We just want triangles that we can just kind of draw all over and get an idea of what's going on. So we'll label them in the same order, L, M, N, R, S, T. So we labeled them both like this and like this, so they're inherently matching up. Now we'll go ahead and use the information they gave us. L and R are both 60 degrees. LN is 10, RT is 30. Now, similar triangles have all the same angles as one another, and the sides are in matching proportions. So 60 and 60 looks pretty good. And if we're using the 10 and the 30, it looks like the triangles will be in a 1:3 ratio. But let's keep confirming. So we need to know which other information will make the two triangles similar. So let's try answer choice A. In A, we have MN as 7 and ST as 7. So this doesn't match any of the triangle rules because we have side, side, angle, side, side, angle. And there's no side, side, angle for triangle similarity. Not to mention, 10 and 30 are in a 1:3 ratio, but 7 and 7 are in a 1:1 ratio. So the proportions don't line up. So nothing's looking that good with answer choice A here. So let's get rid of that. Now let's look at B. MN is 7, ST is 21. This is a little better because we have the 1:3 ratio here, and now we have a 1:3 ratio there, and the ratios are matching. Still, there's no side-side angle rule for triangle similarity. So this is not matching one of the similarity rules. So we'll get rid of B as well.
Looking at C now, M and S are 70 and 60. So M is 70, S is 60. And if each of the triangles has to add to 180, 60 plus 70 is 130. We'd need 50 more to make it 180. 60 and 60 is 120. We'd need 60 more to make it 180. Now, similar triangles have all the same angles, and we don't have all the same angles here. So we don't know that the triangles would be similar based on C. Now, by the way, what are the triangle similarity rules? To find that out, I went to ChatGPT and I used Khan Academy's Tutor Me GPT app. And I asked it, what are the triangle congruence and similarity rules? And here were the congruence rules at first, and here are the similarity rules. And these are things you definitely want to have memorized for the SAT. So thanks to Khan Academy's Tutor Me GPT, we got this great information that we should memorize. Coming over to answer choice D, if M is 70 and T is 50, then we can figure out, well, what else do we need to make the triangles 180? 70 plus 60 is 130, so we need 50 more to make it 180. 60 and 50 is 110, so we need 70 more to make it 180. So when we first set this up, we had the 1:3 ratio here with the matching angles here. So it looked like the triangles were going to be matching in this exact order. But when you look at the angles, they're actually not matching. They are similar though. We would have to say, if we were doing a similarity statement, if I said LMN, I'm going 60, 70, 50. So I'd have to say 60, 70, 50. I'd have to say LMN is similar to RTS. So LMN is similar to RTS, not RST. The order's wrong. It doesn't really matter for this question because all the angles match. We know they're similar. If the angles and sides match, they'd be congruent, by the way. But the answer here is D. Don't wait. Join now for access to exclusive SAT lessons, practice problems, and solutions to questions from the SAT Question Bank.